All right, so homework 33 starts out with introduction of the least common multiple of two monomials. LCM, least common multiple. So when you think about multiples, you think about the word multiply. You're going to get bigger. My multiples of 10, 10, 20, 30, 40. My multiples of 8, 8, 16, 24, 32, 40. So when I'm looking for the least common multiple, it's just like finding that common denominator that we found when we added fractions. My least common multiple of 10 and 8, well, is going to be 40. If you're not sure, start with the biggest number and start doing the multiples. 10 is my first multiple of 10. 8 doesn't divide into 10. 20 is my next multiple. 8 doesn't divide into 20. 30 would be my next one. 8 doesn't divide into 30. 40 is my next one. Oh, 8 divides into 40. There's my least common multiple. When I'm working with variables, I use all of my variables to the higher exponent. So if my variables are different, I'm going to use them both. If they're the same, I'm going to use the highest one because multiples are greater than or equal to my values. So in this case, I'm going to use both the m to the fourth and the a to the third because my variables are different. I have to have both of them. It's like when you have a 2 and a 3, your least common multiple, you have to do 2 times 3. You have to use them both. If I'm going to find my least common multiple of 12y squared and 9y to the fourth then, my least common multiple of 12 and 9 would be 36, exactly. Multiples of 12, 12, 24, 36. Oh, 9 goes into 36. This time my variables are the same. I've got a y squared and a y to the fourth. Since I'm doing a multiple, I have to use the higher one. So y to the fourth is my common multiple. So you had ones that were greatest common factor where you found the smaller things. Greatest common multiple, or least common multiple, you find the bigger ones. So if I'm going to do my least common multiple of 7m squared and 4m to the fourth, I would have what? 28. M to the fourth. And they'll do shorter ones and then they'll get the longer ones. I'm going to add space in there because it looks like there needs to be a space in there. While I'm thinking of it. So number 4. Now we're going to do the least common multiple of my monomials that are longer, that have multiple variables. So least common multiple of 2 and 10. That's a factor. 10 is. 2 does divide into 10 evenly, so 10 is my least common multiple. Then I look at my variables. I've got a variable of u. If I have u to the fourth and a u, I would use u to the fourth because that's the higher one. I've got x's. I've got x to the ninth and x to the fifth. X to the ninth. And I also have a w to the fourth. Just like on those previous ones, you have to use every variable. So even though there's none here, there's 4 here, and 4 is bigger than 0. So I'm going to use the w to the fourth. So my least common multiple, 10 u to the fourth, x to the ninth, w to the fourth. So number 5, if I'm doing my least common multiple of 6 and 8, 24. And then with my variables, I would have what?
B to the eighth.
B to the eighth. W to the ninth.
And y to the sixth.
And y to the sixth. So we had v's, w's, and y's. We want every one of those variables to the higher exponent that's listed. So number 6 here. My least common multiple would be 12, since 2 does divide into 12. U to the fourth.
W to 5.
W to the fifth.
And B6.
And B to the sixth. Exactly. The next ones, we are adding and subtracting rational expressions, fractions, with a common denominator and binomial numerators. Right, they're going to start us out where we already have a common denominator. We don't have to make one. However, we're going to have to distribute if we have a negative in front. So you want to think of this as like having this on top of your fraction with the negative out in front, and that I have to distribute that out. So I'm going to write one big fraction because my common denominator is 8a. Distributing my negative here, negative and a positive is going to make that a negative 6a. A negative and a negative is going to make that a positive 10x. Same thing here, that one has a negative in front. I want to think about it like I have parentheses around the top of that fraction. And so a negative and a positive is going to make that a negative 8a. And then a negative and a positive is going to make that a negative 7x. Now, just like when I add other fractions, I'm just going to work with the numerator. I'm going to combine my like terms. So negative 6a minus 8a would give me negative 14a. Positive 10x minus 7x would be positive 3x over my 8a. Now, the only way I can simplify that is if all three terms are divisible by the same thing. Since they're not, I can't reduce that down any farther. But do be careful when you type this in that when you hit the negative, if you hit the negative before the fraction, it likes the negative in front. The negative needs to be on top the fraction. So I would suggest when you type it in, hit the fraction button first, then type the top in and the bottom separately. Don't try to type negative 14 because otherwise it tries to put the negative in front. You can type it and highlight the whole thing and then hit the fraction. That also works. But just be careful when you type it in that the negative goes on top, not in front of that fraction. So number 8, if I'm going to add those two expressions together, my common denominator is 5a. If I distribute my negative in front of that fraction, what should I have?
Negative 4a minus 2b.
Negative 4a and
Minus 2b.
not minus 2b.
Oh, plus.
Plus, because I'm going to have a negative and a negative, right?
Mm-hmm.
So a negative and a negative is going to make that a positive 2b. This one has a plus sign in front, so if I distribute that positive sign, I'm going to have
Negative 4a.
if I do this part,
Yeah. Negative 8a.
there's a plus sign there.
Plus 8a minus 7b.
It's going to be a plus 8a and a minus 7b. So positive 8 and then a positive times a negative stays negative, right? Now if I combine my like terms, negative 4a plus 8a
4a
is 4a and 2b minus 7b
minus 5b.
minus 5b all over my 5a. And again, I can't divide all three terms by the same thing, so I can't reduce that down any further. That's just going to be my answer. So number 9, 4c is my common denominator. The first fraction is not going to change much because there's nothing in front of that. So 8c minus 11d. On the second part, I'm going to get what?
Minus 6c plus 6b.
Minus 6c and a plus 6d. So a negative with a positive is a negative, and a negative, change that to a positive. But when you have that minus in front, it just changes my signs. Combining my like terms, 8c minus 6c. 2c, negative 11d plus 6d is
Minus 5b.
minus 5d. Over my 4c. And again, I can't divide all three terms by the same thing, so I can't simplify that. Every once in a while, they'll throw one in that you can reduce, so you do want to watch for that. The next ones are complex fractions without variables. A complex fraction just means you have a fraction within a fraction. think of fraction as divisions. This line here is dividing those two things up. So this problem really could be 7/16 divided by 5/14. When we divide fractions, we have to invert and multiply, or use our calculator, but you know, hey, 7/16 times 14 over 5 then is what we would do on our paper if we're not using our calculator. I can't reduce the 7 and the 5, but I can reduce the 14 with the 16 because they're both divisible by 2. 2 goes into 14 7 times, 2 goes into 16 8 times. And then we multiply. 7 times 7 is 49, 8 times 5 is 40. They're just going to have you leave the improper fraction. If you use your calculator, you'll get the mixed number, and you'll have to change it to an improper fraction. Because on Alex, they don't want you to put the mixed number in. So, on the next one, it's a little hard to tell where the actual bigger line is supposed to be, because when she typed them in, the line didn't get very big. But I believe this was supposed to be like that. 7/6 over 4. So, if this was 7/6 divided by 4, how do I rewrite my problem?
7/6 divided by 4 over 1.
7/6 divided by 4 over 1, I could do that. And then I would do it as multiply by 1 over 4. 7/6 times 1/4 gives me 7/24 for my answer. On Alex, it'll be a little easier to see where that bigger line is supposed to be. Here it should be between those two fractions again. So 6/7 divided by 3/5. We are going to write as
6 over 7 times 5.
6/7 times 5/3. I can reduce that one a little bit.
3 goes into 6 twice.
3 goes into there once and into there twice, and so I get
10 over 7.
10 over 7 for my answer. Easy enough, right? And the last three, now they made them a big mess. Complex fractions, but now we've got a whole bunch of variables and stuff in there. Same kind of rule applies. If I were to rewrite this, here's where my fraction bar would be. I would say 15s to the 4th over 3t to the 5th u cubed divided by 5rs squared over 9t squared u. So again, since we're dividing fractions, we end up inverting and multiplying. So 15s to the 4th over 3t to the 5th u to the 3rd times the reciprocal, 9t squared u over 5rs squared. So this one doesn't have repeats of variables in it, so we can just go ahead and do canceling in there. We can reduce the 5 and the 15. 5 goes into here once, into here 3 times. We can reduce the 3 with the 9. 3 goes into here once and into here 3 times. Looking at my variables, I've got an s to the 4th and an s squared. So I can take out 2 of my s's. Leaves me an s to the 2nd up here on top. I've got t's, t to the 2nd and t to the 5th. So I can take out 2 of my t's, cancels that one out. Leaves me t to the 3rd on the bottom. Looking at my u's, I can take out 1 of my u's. Leaves me a u to the 2nd. So if I can keep track of all that mess and scribbling, on the top I have a 3 and an s squared. On the bottom, I've got a t to the 3rd, a u to the 2nd, and I have this r hiding in there. I'm going to put it in front just because I like it in alphabetical order, not that it makes any difference. Just be careful that you don't forget that little r smushed in there hiding that didn't get canceled out.
Wouldn't you have to times 3 times 3?
Where are you doing? Oops. Yes, I would. See, good thing you're paying attention. 3 times 3, I better do that right. I missed that 3 up there. 3 times 3 should be 9 up there on top. So 9s squared over rt to the third u squared. Good thing you caught me. So probably, is it really necessary to write this step down? Probably not, because hopefully now you know that that's a dividing problem, and we're just going to invert and multiply. So on number 14, if we just go to that, we are going to take 7mn squared over 12x to the third y times the reciprocal of the denominator, so 3x to the fourth y to the fourth, over 28 n to the fourth. So if we invert and multiply, what can we do with that one?
7 goes into 28 4 times. 3 goes into 12 4 times. And then you can cancel the n squared and then put n squared over there. Take out 1y, so that'd be y to the third on the top. And then 1x on top by.
Okay, we'll take out x to the third, which leaves us a plain x on the top. So, on the top, we are left with
mx y to the third.
mxy to the third, and on the bottom, 16n squared. Exactly. One last one on this one. So again, we are dividing our fractions. We have to invert and multiply. So 21c to the third d over 5ab squared times the reciprocal, so the 10b to the fourth will be on top, and the 7c to the fourth d to the third going to be on the bottom. So, multiplying our fractions, we can do what?
7 goes into 21 3 times.
7 goes in there once and into there 3 times.
5 goes into
5 goes in there once and into there 2 times.
10. Cancel out the c to the 3, take the down to c.
Cancel out c to the third.
Cancel the d.
Cancel out one of their d's.
And cancel out b to the second.
Cancel out the b to the second.
B to the second.
And so on the top we're going to get
6b to the second.
6b squared, and on the bottom,
a c d 2 squared.
acd squared. Exactly. Alrighty, that's the next 5 things. So on chapter 6 we've covered 11 of the topics.